Welcome to our new video. Today we have a fascinating problem to tackle. The task at hand is breaking down a graph network into 5 connected subgraphs, ensuring that each node appears exactly once. It sounds like a challenging problem, but with the right approach, we can crack it. Let's dive into the solution. We have a cleverly crafted function that randomly selects vertices from the graph as initial members for each group. It then iteratively grows each group until all vertices are assigned to a subgraph. The code efficiently handles the partitioning process, ensuring connectivity within each subgraph. Next, we execute the function on our original graph to witness the magic in action. The output showcases the groups formed, along with the vertices in their respective counts. The solution seamlessly divides the network into 5 connected subgraphs, maintaining the graph's integrity throughout the process. To put the solution to the test, we ran a performance check on a larger 100 by 100 grid, partitioning it into 10 groups. The function performed admirably, swiftly dividing the extensive graph into distinct subgroups with efficiency. The resulting subgraphs are well defined and maintain the connectivity of the original network. In summary, we've successfully tackled the challenging problem of breaking down a graph network into connected subgraphs. The implemented solution handles the task with finesse, showcasing the power of strategic algorithm design. If you enjoyed this video, don't forget to hit subscribe, like, and comment below with your thoughts. Remember, even in a network of nodes, staying connected is key.